Alright, hi guys, sorry I couldn't be there today. Today I'm going to teach you about how to find the surface area of pyramids and cones. Now, yesterday we labeled all of the different shapes as either prisms or pyramids, and then cylinders and cones. We talked about prisms and cylinders on Friday, and then today we're going to talk about the ones that actually come to a point, which are the pyramids and the cones. So let's define pyramids a little bit more. Pyramids, just like everything else, are named based on their base. They have only one base. That's the real big difference between a pyramid and a prism. Their lateral edges meet at a point that we call the vertex. That's the tip of the pyramid. And lastly, their lateral faces are always triangles. As opposed to prisms where the lateral faces are rectangles. For a cone, the only difference is that the base is a circle. Now, when we're finding the areas of these shapes, we're still going to do it like we did on Friday, where we're going to find the area of the base and then what's called the lateral area. So the total area of a pyramid is going to be the area for one base plus the lateral area. Now to find the lateral area for a pyramid or a cone, it's a little bit different. You're going to do the 1/2 perimeter of the base times the slant height. Now the slant height is the height on the side of the shape, not directly down the middle from the vertex. That's the true height. We'll be using that with volume, but the slant height is the height of like the triangle lateral edge. I'll show you when we get to the pictures in a couple minutes. For a cone, it's still that same formula, lateral area plus the area of a base, but just like we talked about the other day, lateral area is going to be 1/2 circumference times slant height, and for the base of a circle, you always know that that area is pi r squared. I'm just going to add for a cone that the lateral area is found by 1/2 times the circumference times the slant height. Okay, so let's go ahead and give some of these a try. Okay, so let's take a look at some examples. You may have to draw these pictures on your note sheet, or you can take a picture of your neighbors who has the physical copy of the paper. Sorry, the pictures didn't transfer over. Alright, so the first one is a square pyramid, which means we can easily find the area of the base by doing the side squared. The length of the side is 4. 4 squared gives you 16. Alright, that's the easy part. Now we need to find the lateral area, which means that we need to do 1/2 the perimeter of the base. So we can get the perimeter of the base, 4 plus 4 plus 4 plus 4 is 16, times the slant height. Now this is the new part. To get the slant height, we need to find the height that's right here on a triangle. Not this height that goes right down the middle of the shape, but this height over here that goes down the side of the triangle. So what we're going to do is we're going to actually draw in a right triangle. We know this part is just 2 because it's half of the length of the side. And now we have a right triangle with sides length of 2 and 9. Now you remember you can always find the third length in a right triangle using the Pythagorean theorem. Sometimes this will be a family, sometimes not. So in this one, I'm getting the square root of 85 to be the length of the side of the triangle, or my slant height. So that's what I'm going to plug in when I'm finding lateral area. So then the lateral area of this shape, half of 16, is 8. So this is going to be 8 root 85. And then to get the total area, all I'm going to do is add those parts together. So 16 plus 8 root 85 units squared. Okay, the next one is the same shape. Oops, I forgot to put your labels in. Where they tell you this part here is 10 and the base is 12. So 10 this time is the lateral edge, but remember we still need to know the slant height. Let's start with the easy part again. So let's start with the area of the base. Since we know this is a square base, we can say the area is 12 squared, or 144. Now for the lateral area, we have a little bit more work to do. First, I'm going to actually create a right triangle with my slant height. So instead of creating the triangle this way, like we did the first time, the right triangle I'm actually going to look at is going to be right here. I've got half the base, the slant height, and this part. So half the base is 6, this lateral edge here is 10, and then I know that this is actually a family, so my slant height is going to be 8. So this time I'm going to do 1/2. The perimeter of the base is 12 times 4, or 48, times the slant height, which I just figured out to be 8. So again, remember slant height goes along the side of the triangle, not the height directly in the middle of the triangle. Alright, 1/2 48 times 8 is going to be 192. So that's my lateral area this time. And then to get my total area, I'm just going to add those two numbers together. So 144 plus 192 gives me a total area of 336 units squared. Okay, the last two problems are both cylinders. Again, we're going to have to really pay attention to the real height versus the slant height. In this first problem, we actually have everything we need. We can find the area of the base first by just doing pi times the radius squared. So you get 25 pi. And then for lateral area, we want to do 1/2 the circumference, which is pi times diameter, or 10 pi, times the slant height, which is the height that they gave us this time, 6. So half of 10 is 5 times 6. My lateral area is going to be 30 pi. And then my total area, when I add these together, 25 pi plus 30 pi gives me 55 pi units squared. Okay, now the last one, again I can start with the area of the base, that's an easy part. Area of a circle, pi times 5 squared gives me 25 pi. But this time the height that they gave me is the actual height, not the slant height. I need this height right here. So again, I have a right triangle. It's not a special family, but I can do 5 squared plus 18 squared equals x squared. 18 squared is 324, added to 25 gives you 349, and there are no perfect squares that go into that, so I'm just going to leave it the square root of 349. Okay, so now when I'm finding lateral area, I'm going to do 1/2 circumference, which again is 10 pi, times the slant height, root 349, so I get 5 pi root 349. And then my total area is going to be those parts added together. I can't combine it because it has the root, so I'm just going to say 25 pi plus 5 pi root 349. Alright, give it a try. We'll talk about it tomorrow. And then you can check your answers from last night's homework on my Schoology page as well. Good luck.